when you make the acceleration constant. So what that means is you get to speed up, slow down, or change direction at a constant rate. That's what it means. So the motion itself becomes predictable when you make the acceleration constant. So the next question is, what aspects of motion become predictable?
Distance traveled.
All right, so we will build on a couple of things. We will build on just about everything that we learned up to this point in terms of terminology. Okay, so what do we know? You're going to fix the acceleration, so which means that this acceleration is going to be constant. In this case, you're speeding up. And notice that your velocity is going to be changing within a certain time period. Also, you can traverse a certain distance within that time period. So that represents the distance that you will traverse. All right, so there are two things about this motion will become predictable. Location is going to become predictable, x, at any point in time, and also the speed is going to become predictable at that time, also at that location. All right, so we will have three formulas.
In the formula sheet, it says the first formula has a plus and minus. Does it matter which one?
All right, Christian, just hold on. Give yourself 2 points. That's a good question. Okay, so notice that there are three things. We got three formulas. Three formulas describing two things. X is the location, V is the speed. So if you fix the acceleration to a constant value, you're going to be able to locate the object at any given point in time. So this locates the object for you at this time. So this is the location of this object. The object is located right here within this time period. So the first formula is going to locate the object for you. Second formula is going to tell you how fast the object is moving at that time. So this many seconds later, this is how fast the object is moving. The third formula is going to give you the speed of this object at that location. All right, so the first formula locates the object for you at a given point in time. The second formula tells you how fast the object is moving at that time, as well as at that location. All right, so two things become predictable. Location becomes predictable, and the speed becomes predictable when you fix the acceleration to a certain value. So when you fix the acceleration to a certain value, those two things become predictable. All right, so let's go to the formula sheet and find these formulas. So these are the uniform motion formulas. Okay, so I'm just going to grab these, copy those. All right, so these are the same formulas as the formulas that I just gave you. Open this up. Maybe not. Open this up. All right, so these formulas are the same, except there's a slight difference. Okay, so what's the difference? The difference is I'm using pluses here, and these are pluses and minuses. All right, so when do you use plus, when do you use minus? Okay, just for now, until stated otherwise, I want you to just use the plus sign, okay, until we start covering the minus sign. Okay, just for now, everything is speeding up. Acceleration is a positive acceleration, so just use that. Okay, so I'm going to give you guys 5 points for each and every single question. All right, what's the meaning of the first formula? What does it signify?
Locating an object.
Yeah, you find the object.
Okay, I'm going to give you 2 points so far. I need more.
Location at any given time.
Okay, very good. That's 5 points. If you know the time, you know the location. That's what it means. If you know the time, you know the location. Notice that the location becomes predictable. All right, okay, what's the meaning of the second formula?
How fast?
The speed at any given time.
Okay, very good. If you know the time, you know how fast it's moving at that time. Speed at a given time is what you find. So if you know the time, you know the speed. Okay, what's the meaning of the third formula?
Calculating velocity without time.
All right, I'll give you 2 points for that one. I need a concise definition of it.
If you know distance, you know velocity.
Okay, very good. If you know the location, you know how fast it's moving at that location. All right, so story that you get from this. The first one says, if you know the time, you know the location. You know how fast it's moving at that time, and you know how fast it's moving at that location. So that's what it means. Okay, so which means that the motion becomes predictable when you fix the acceleration.
Excuse me, what was number 2 again? If you know the time, you know the acceleration, velocity, I mean?
Yeah, that's precisely correct. So if you know the time, you know exactly how fast it's going at that time, right? So if it's NASA, for example, you know you got 8 minutes. All right, so if you fix the acceleration to your right value, within 8 minutes, you should be 180 miles away, for example. Okay, provided that the acceleration is fixed. If the acceleration is fixed within 8 minutes, you should be moving at 17,500 miles per hour. If the acceleration is fixed, if you're 180 miles away, you should be moving at 17,500 miles per hour. So everything is related to fixing that acceleration. So how does NASA make motion predictable? They make motion predictable by fixing the acceleration. So that's how you make motion predictable. All right, so how does one make motion predictable?
Eliminate jerk.
Yeah, you
Eliminate
Making
acceleration as
acceleration
constant.
constant.
okay, by making acceleration constant, right? So what aspects of motion become predictable at constant acceleration?
Position and speed.
Location and
That's it,
speed
very
of
good.
an object at any
Given time and okay, so location becomes predictable, speed becomes predictable at a given time at a given location, right? All right, that's it. Okay, conceptually, that's it. Okay, so uniform acceleration is going to make motion predictable. So motion becomes predictable when the acceleration is constant. So we got three formulas. First formula is going to locate the object for you at a given point in time. Second formula is going to tell you how fast it's moving at that time. The third formula is going to tell you how fast it's moving at that location. All right, so three formulas that we will get to use, and for now we will only use the pluses. Okay, pick out the best answer. All right, so I see a lot of D's. Very good. D is the best answer, right? A is correct, B is correct, C is correct. First formula, second formula, third formula, D is the best answer. So give yourself 5 points for that one. Okay, very good. I'm looking at a lot of A's. So A is the best answer. So give yourself 5 points. So speed of an object at any given location. So that's the third formula. Okay, once again, I'm seeing a lot of D's. Location of an object at any given point in time. That's the first formula. So location as well as the speed are going to become. All right, so problem number 7 from the handout. Uniform acceleration. All right, so find the problems. Problem number 7. All right, so problem number 7 is the one we will focus on.
Inshore racing. These are Formula One powerboats. Just 17 feet long, they accelerate from 0 to 100 in less than 4 seconds. Top speed, 140 miles per hour. A boat that takes 90-degree turns at breathtaking speeds. Inside a cockpit modeled on an F-16 fighter, the driver controls the machine with pinpoint accuracy. The slightest mistake could mean death. This is the most dangerous form of powerboat racing on Earth. Formula One boats are made of fiberglass, carbon fiber, and wood. They weigh a mere 350 pounds. When they crash, there's not much left.
All right. Let's turn this into a problem.
Inshore racing. These are Formula One powerboats. Just 17 feet long, they accelerate from 0 to 100 in less than 4 seconds.
All right, so 0 to 100, less than 4 seconds.
Top speed, 140 miles per hour.
All right, so determine the acceleration and determine how far they travel while reaching that final speed, 100 miles per hour. Part C, I'm going to skip. All right, so let's take a look at the problem the way it is stated from the problem sheet. It says it goes from 0 to 100 miles per hour within 4 seconds. So 0 to 100 miles per hour within 4 seconds. All right. So how far does it travel? That's part A. And then you try to solve the problem. Immediately, you will notice that there isn't enough information available. Case in point. All right, okay, let's do the conversions first, I think. Miles per hour to meters per second. All right, so we got these are the only symbols we got available. And then you try to pick the right formula only to realize that it's not possible. So look at your symbols and pick the formula that only has those symbols. And then you are thinking, oh, this has X, so this is no good. You cannot use that. All right, so using these symbols, you will notice that you don't have a symbol for A. If you don't have a symbol for A, if you don't know what acceleration is, you won't be able to use any one of them. So I decided to change the problem around just for now. I don't want to make it too complicated. So the best thing to do is just find the acceleration first and then find the distance later. All right, so let's figure out the acceleration first. All right, now it's straightforward. The only thing you have to do is just look at your symbols and then find the formula that contains those symbols. Notice that X is not given to you, so you can't use the first one. X is not given to you, so you cannot use the last one. This is the only one you can use. All right, so this is the formula, so you just have to solve for A. Okay, we're not going to use any numbers. I'm not going to let you use any numbers except zeros. If you have a zero, just plug it in. And this is a simple enough case, so the initial speed is 0, so that's what we will use. So that term is going to drop out. Acceleration times time is velocity, so I'm going to move things around to get the acceleration term on the left-hand side. Now, divide both sides by t, and that's it. Okay, so this is what the final equation looks like. All right, so into which you plug the numbers with metric units. All right, so it gives you the acceleration in terms of meters per second squared. The next step is express it in terms of g's. Notice that I employed the trick that I was talking about before. I just moved the decimal to the left. It gives you a g load. So in this case, acceleration that you feel is going to be slightly more than your own body weight in this case. All right, so we're done with that. All right, the next step is let's check to see how far it travels while reaching this speed of 100 miles per hour. So x is what we need, and then express it in terms of feet. All right, so the only formula that makes sense you can use under the circumstances, guys, you got two formulas. This says x in it, so it's this one. All right, either one is going to work. You can use the first one or you can use the last one. I'm got to be lazy in this case. I'm going to use the first one because x is already on the left-hand side, so why not use that? And notice that the initial speed is 0, so it's going to knock out the first term. 0 times t is 0, so that's going to drop out. So you got 1/2 at squared. So now use the numbers in metric units. Okay, for acceleration, this is what you need to use. And time is going to be 4 seconds. So square, don't forget to square that. And you got the number in terms of meters, not conversion to feet. It's about 300 feet. That's it. Okay, so this is a good exercise in terms of how you pick formulas in this case. This is kind of high school style. We're still working on the formatting. So that's how it is done. All right, so you pick the initial formula based upon what's given. Okay, you guys got it. Formulas, the symbols on the right-hand side, measurables on the right-hand sides are instantaneous speeds or instantaneous values. Very good. B is the best answer for that one. Okay, so let me give you a bit of a puzzle. So let's have a quick discussion regarding this. All right, so Navy fighter jets, their takeoff speeds are 140 miles per hour. But there's no way they can get up to that speed on their own. There's no way. All right, so if they cannot get up to that speed on their own, how do they ever reach that speed? How does that happen? Any ideas?
They use a slingshot.
Yep.
Okay, so Arun, you said they use a slingshot. All right, how do you know that they use a slingshot?
I've watched it in documentaries
Okay,
where
very-
it accelerates very quickly.
Okay, very good. Give yourself 10 points. All right, they use a slingshot. They're usually catapulted. All right, and because they're being catapulted, they try to make motion as predictable as possible, so they use uniform acceleration. All right, so I'm going to give yourself 10 points for the experience. Some of you guys are veterans, so you guys have the life experience. So